Hi. In today's video, we're going to look at how to translate a sentence to an equation and solve it. It is super important that we are able to translate a description of a problem into equation or equations, and then solve it. If the translation part is wrong, then nothing going to be right. You don't need to solve it, right? Because your representation of the original information is wrong. So being able to translate a description, in our case, a sentence into an equation is critical. Okay, now this is the only objective we have in this video. Here are some very basic translations, and everybody should be able to do. So let's take a look at it. For the addition, we have several different ways to indicate we have an addition description. So the sum of two numbers, right? The sum of x and 3. So you add these two numbers together. Even though one of them is unknown, we use a variable to represent it. But ultimately, it's the sum between two parts. So you add them together. And the second one is very straightforward. H plus k, a number plus another number, right? H plus k. T added it to 7. So you have 7 comes first, then you add t to it. Even though the order in addition doesn't matter. So either way is okay. This t added to 7. This just emphasize that 7 comes first, then you add t to it. You can also write t plus 7, there's no difference. Now, now let's look at the next one. 3 more than some number. Some number is unknown, so we use a variable to represent that, such as n. So 3 more than that, you add 3 to it, you got something 3 more than that. And the next one, y increased by 2. You have to have y first before you can increase it by another amount, right? So y plus 2. And now let's look at the subtraction. The difference of 3 and x, we all know in subtraction, the order makes difference. Say 5 minus 3 is not the same as 3 minus 5, right? That's why we need to pay attention to which number should be the first in subtraction, which should be the second. Usually the first one that appears in the description will be the first number. So the difference between 3 and x is 3 minus x. H minus k, this is a straightforward one. 7 subtracted from t. So you have to have t first before you can take away some number from it, right? That's why t goes first. And 3 less than a number. It's very similar to the previous one. You have to have that number first before you can figure out the other number that is 3 less than that. That's why this a number goes first. So that's n first and minus 3. The last one, 2 decreased by y. So you reduce this 2 by the amount of y. You have to have 2 first before you can reduce it, right? So 2 minus y. So this is some examples of addition and subtraction descriptions, phrases. Now let's look at multiplication. The product of 3 and x. Product is the result of multiplication, right? We just multiply the 3 and x. And next one, 4 times k. So apparently 4 times k is a straightforward one, just like h plus k, right? And third one, some number multiplied by 5. So in terms of reading, this is some number which is variable comes first, then that number is multiplied by 5. So we're supposed to write n first, then multiply by 5. But in mathematics, the convention is that we put number in front of the variable in multiplication, okay? Next one, twice a number. So double a number using 2 multiplied by that number. Triple a number, pretty much like this one. It's just a triple instead of double. Now let's look at some keywords for equal sign. Right? When you set up the equation, you have to identify which part equals which part, right? So we need to identify the words that give you the equal sign. Now here are some examples. Is equal to, is the same as, is, produces, yields, results in. They all indicate the equal sign, represent the equal sign. Now let's look at our first example. Translate to an equation, then solve. So let's look at the first one. The sum of 17 and the number is equal to 15. So this is our equal sign. So this part equals 15. So what is this part? The sum of 17 and the number. Sum is result of addition, right? Sum of 17 and a number we don't know, we use a variable to represent that. And this is sum equals 15. So we translate this description, this sentence, into an equation in a very natural way. Now we solve it. We already know how to solve this simple equation from the previous video. So we just move this number we don't want to the other side so that the variable is on one side by itself. We also mentioned in the previous video that whenever you move a term to the other side, to the opposite side of the equal sign, you change the sign to the opposite too. This is a positive, become negative. So our x is -2. 15 minus 17 is -2. Now let's look at our next example. 12 12 less than some number is 10. Some number is unknown, that's our x. You can use n, you can use any variable. So 12 less than that, take 12 away from that, and it's 10. So solve it, move the -12 to the other side, x equals 10 plus 12. So that's 22. So we know this is the correct answer. We don't even need to check because 12 less than 22 is 10. So we know that's true. Now, next example C, the product of 7 and y is -35. The product is that's equal sign, -35. The product is result of two parts multiplied together, and those two parts are 7 and y. These two parts multiplied together is -35. So we divide by 7 on both sides to cancel 7. Y is -5. So we solve it. Now this is your exercise questions. Let's do this. And answers to all of the exercise questions is in the comment area below the video. Next one. Translate to an equation, then solve. 7 more than the product of 3 and r is equal to 19. So a little bit more complex in terms of description. Equal to is equal to 19. So that means this whole thing before that is on the left-hand side of equal sign, right? It's equal to 19. And this part in the box is 7 more than the product. So you have to have product first before you have something 7 more than that, right? Product is between 3 and r. So 7 more than 3r. So add 7 to it. So 7 more than 3r is equal to 19. So now we can solve it. Move 7 to the other side. 3r equals 19 minus 7. So 3r equals 12. r equals 4 if we divide both sides by 3, right? We solve it. Now, second set of exercise questions, translate and then solve. Now, move on to our example 3. Say, notice that the description is getting longer, right? Gradually. Translate to an equation, then solve. Twice the difference of 5 and n is the same as 17 subtracted from 7 times n. So identify keywords that give us equal sign, which is the same as. After that, we realize this part is on the right-hand side of equal sign, and this part is on the left-hand side of the equal sign. So we just look at this part, these two parts one by one. Twice the difference of 5 and n. We have to have difference first before we can do double of that, right? So difference is the result of subtraction. Difference of 5 and n, twice of that. Since we have to have difference first, which is the result of subtraction, then we double that. But double means multiplication. But we have to have difference first, subtraction first. Subtraction has a lower priority than multiplication in terms of the order of operations, right? So in order to do this difference first, we have to use a parenthesis to make this priority at higher level, to a higher level. So twice of that, twice the difference is the same as 17 subtracted from 7 times n, 7 times n, and 17 subtracted from it. So this is the translation. So this translation has to be correct. Otherwise, the whole thing is wrong. You don't need to solve it, right? Okay, now let's solve it. Whenever you solve an equation with parentheses in it, generally speaking, you need to do distribution to get rid of the parentheses so that you can move the terms around so that you can combine like terms. So 2 times 5 is 10. 2 times negative n is negative 2n. Remember, after you multiply by 5, 5 is gone, it becomes part of 10, then you only have negative n left. So 2 times negative n, that's negative 2n. The other side, 7n minus 17. Now we need a variable on one side, number on the other side. That's why I need to move these terms. So negative 2n to the right-hand side, at the same time, negative 17 to the left-hand side. So 10 plus 17 equals 7n plus 2n. So whenever we move a term to the opposite side of the equal sign, we change the sign to the opposite too. So negative 2n become positive 2n, negative 17 become positive 17 here. So 27 equals 9n, apparently n equals 3. So we solve it. And let's see if we have more example. We have more exercise for sure. Yeah, this is the last one actually. We don't have any more examples. This is your last set of exercise questions for this video. If you have any questions, make a comment in the comment area. I will do my best to answer your questions. Okay, that's all for this video.